Good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, today in our lesson, we are going to continue on to looking at the different processes in the water cycle. From the previous or the last lesson, we have already covered the two processes, which are evaporation and condensation. We did have those students who presented on precipitation, but we did not allow for questions to be actually asked. So today, what we are going to do is we'll start off first with the group on condensation to explain a question that was asked and they were supposed to research on. And then we will have the group that did the work on precipitation to come back up front here for any questions to be asked on that process. And after that, then we'll continue on with the other presentations. So we will now start off with the question that was asked to the group for the work on condensation.
A question was asked by a student from this class: what is adiabatic cooling? Okay, adiabatic heating and cooling. It's the irregularities in the Earth's surface, such as orographic barriers, may cause a type of temperature change in the atmosphere. The above rate of increase or decrease of temperature of moving air is otherwise called the adiabatic lapse rate, or more specifically, the dry adiabatic lapse rate. The dry adiabatic lapse rate refers to the rate of temperature decrease or increase of an unsaturated air mass. It has to be distinguished from saturated air or wet adiabatic lapse rates. That's to answer the question.
And referring back to Mason's question, he said, is there a possibility where would clouds be formed if he was to boil a kettle? The answer is no, as I said yesterday. But other forms of condensation, such as steam, mist, fog, smoke, or dew, may form.
Okay, and that's to look at perhaps those questions which were outstanding and that needed to be clarified or answered. Thank you. To help that group with the work on adiabatic lapse rate and the dry adiabatic lapse rate plus the saturated adiabatic lapse rate, there is a handout now which I have actually put together, photocopied for you. So you will be expected to actually read through to see if you understand the difference between the concept or the term that has been used on condensation. Okay, we'll get one between two, and if there isn't enough, then you can have one to yourself. Okay, the next group, this time for the work on precipitation, could you also come up front now? And questions for that group, if there is any questions to be asked. Any questions on precipitation? Okay, Mason has a question.
The question is, what factor or what causes the rain to be heavy or light or drizzle, kind of drizzle type?
If the rain droplets come down, and if the droplets pick up any bits of solid particles in it, then they come down heavy. But if they just come down without picking up much particles, then they come down light.
Other questions? There's a question here.
What is the difference between ice crystals and snow?
I'll give it to my fellow to help answer that question.
The difference between ice crystals and snow is that snow s- snow are crystals of feathery or needle-like structures, and ice crystals are they can either be round or in any geometrical shape and solid.
Any other questions? Okay, Gibbs, there's a question. Up here. Okay, we'll come back to the front.
When factories they produce gases, does it affect the rainfall? If like polluting the rain, if yes, then can you explain, please?
Yes, factories, the pollutants from the factories, they affect the rainfall by putting so much carbon dioxide in the atmosphere. It makes it causes the rain to be acid, and it from there the clouds carry the acid rain out to the farms, and they fall down, and from there they can pollute the crops out there. Thank you.
Kieran has a question. That's the second last one. Or from here. Was there a question? Okay. Second last question from here, and the last one will come from the front row.
Can haze be regarded as a form of precipitation?
It's not a form of precipitation. It's not a form of precipitation because it's a suspension of particles in the air. Or it can be, it's naturally occurring like sea salt or dust, desert dust. And it can be man-made like smoke from the burning of fossil fuels.
Okay, and the last question from the front.
Yeah. Do all cloud types in the atmosphere fall as precipitation or rain?
Can you repeat the question?
Do all cloud types in the atmosphere fall as precipitation or rain?
Only the clouds which are classified as rain clouds.
And because I said that was the last question, I think most of the questions on precipitation has been answered by this group here. We'll put our hand together then for the group. Okay, then we move on. The next group to do their presentation will be for the next process now. So the next group, if you can come up to the front for your presentation. Is it yours?
Good afternoon, class. My group and I are gonna expand on the process in filtration. Firstly, I'll define the way then my fellow mates will describe on the process. Infiltration is the process whereby water flows downwards through small openings in the surface layer of the soil.
Infiltration depends on certain factors, and we're gonna further explain on the factors. The first one is intensity of rainfall. Rapid rainfall are unlikely to be absorbed and run off the surface more quickly. This means that if there's more rain, it soaks the soil, so it can't infiltrate, so it just runs off the surface. Yeah. So it may the intensity of rain, it can be a factor which affects infiltration.
About the first diagram, as water passes through the soil and rock, it becomes groundwater. This the groundwater. Groundwater is the water which exists in the ground, having infiltrated from the surface. Two broad zones can be recognized with reference to the vertical disturbance of groundwater. The zone nearest the surface is known as the zone of aviation. This zone is generally unsaturated except after rain. The lower layer is the saturated zone. The top of which layer is the saturated zone is referred to as the water table. Yeah, right here, water table. Yeah. In the zone of saturation, all pore spaces are filled with water, and free-flowing water is present. Groundwater is carried downwards by gravity and then tends to be moved by pressure. It can move in any direction, including vertical. Rates of traveling of groundwater are highly variable, from nearly 0 to a meter per second, but the mean is probably centimeters in a day.
Another factor which affects infiltration is the vegetation cover. Some surfaces, such as a forest, have a large surface area to intercept rain. The passage of rain is therefore delayed. So if there's a lot of vegetation, water doesn't pass through to get into the soil quickly, so it's delayed. But if there's not much vegetation, the rate of infiltration is a bit faster.
Another factor that has an effect on infiltration is porosity. Porosity refers to the total volume of open space in a given volume of rock. It is the ability of the rock to store water. So like what it simply means, like if it rains and if the rock has the ability to store water, then the water will simply seep into the rock and then infiltration takes place. Another of infiltration factor is the permeability. Permeability is the ability of the soil or rock to transmit water. The final, one of the final factors which affects infiltration is the intensity of rainfall. This is when rapid rainfall are likely to be absorbed and run off the surface more quickly. This diagram here. Rock types which are suitable for groundwater supply from wells must have a fairly high porosity and permeability. Such rocks are known as aquifers, as shown here. Rock types which are good aquifers include sands and gravels, chalks, and recent volcanic rocks. Rock types which are not suitable sources of groundwater because they have a low permeability are called aquiclides. Rock types which are usually aquiclides include shales and clay stones, silts and clays, and most igneous and metamorphic rocks. Underground water moves by gravity and pressure towards the nearest outlet, as shown here by the first diagram. The places where water usually comes to the surface are the beds of rivers and lakes, beneath the sea and springs. The vast majority of groundwater seeps unnoticed into the beds of rivers to be returned to the oceans. It is this steady supply of water that keeps rivers flowing for weeks or months after rainfall. When water is forced to the surface at a single point, this concentrated groundwater outflow is called a spring. It occurs where an aquiclide intersects the land surface. When rocks are arranged so that an aquifer slopes downwards from the intake beds and is overlain by impermeable rock, a well can be sunk into the aquifer and water will rise to the surface under hydrostatic pressure. The well is known as an artesian well. Artesian wells have considerable economic effect, have proved beneficial in terms of the economy. They help with drinking water for cattle, sheep, and livestock, especially in desert areas. Examples of places which have used artesian wells are Queensland and New South Wales in Australia. Artesian water returned to the surface will eventually find its way back into the water cycle through evaporation.
Sorry, my friend was supposed to explain the antecedent rain. This is the amount of rainfall which has fallen recently. A spell of wet weather may saturate soil and prevent further infiltration. Questions?
Okay, from the class, any questions for this group on infiltration? Okay, Susan has a question at the back. Microphone, please.
What is the water table?
Okay, a water table is a level below which the ground is saturated. Any hole in the ground will fill with water when the water table has been reached. This level often fluctuates with rainfall, and the water table is thus the upper surface of the groundwater. Answer your question?
Okay, any other questions? Okay, in front, Val has a question.
Could you explain what hydrostatic pressure is? Hydrostatic pressure.
Hydro and hydrostatic basically means water. So when we talk about hydrostatic pressure, we just talk about pressure that is exerted on the rocks in order for the water to come out.
Okay, and one from Gibbs, the question there, perhaps the last question also. Oh, you have one. Okay, second last. Sorry, not the last.
Does it take years or days for infiltration to occur?
We don't really know, but it depends on the amount of water that infiltrates into the soil.
In other words, when the amount of rain falls, it depends on the porosity and the permeability of the rock to allow the amount of water to go in.
Okay. And the last question here. Your question, Shelley.
Can you explain further on antecedent rainfall?
Antecedent rainfall, it means like the previous rainfall which has fallen the previous day, and if it's too much rainfall, it won't go into the ground. Yeah, it won't infiltrate because there's a lot of water in the soil, so it just runs off the surface. But if there's not much rain, then it great. Yeah, it's just the same as intensity of rain.
Okay, and because I said that was the last question, let's put our hand together for the group one. Okay, reading out from the dictionary on the definition of the water table and from what they have presented already here. You look at the water table, it is the level of water under the surface. You won't find it on the surface, it's under the surface that after infiltration has taken place, that level or the top part of the water under the surface makes the water table. And if the water table during the rainy season can rise, that's the top part of the water under the surface, and during the dry season, the water table can drop. Where the water table meets the surface, you might have springs and lakes and etc. We'll ask, can you ask your question again?
So the water table is actually just water?
Yes, it is.
Okay.
The water table is the level of saturation under the surface. For the water table to occur, you must have infiltration. And infiltration is already explained through the different rock types until you come to the impermeable rocks whereby water cannot further infiltrate. And once the water reaches this layer under the ground, then the water rises. The top part of the water is referred to as the water table. Or another term we use is the level of saturation. Okay, thank you. And we'll have time for the next group for their presentation. I'd like you all to be standing on the side of them.
The processes of evaporation, condensation, and precipitation are responsible for the cycling of water from the oceans to the land areas. If the water cycle is a circulatory system, there must be a mechanism which removes the water from the land and keeps the cycling going. Some of the water which falls on the earth will be stored as snow and ice and in lakes and man-made storages, but much of it will continue to move through the cycle in the process of infiltration and runoff. Surface runoff is one of the small but vital process within the water cycle.
The definition for surface runoff. Surface runoff is the process that occurs when proportional of rainfall falls on the Earth's surface, causing water to run off over land, either as channel flow or over land flow, if there is no infiltration occurring.
If precipitation occurs on higher regions, higher than the sea level, the water particles still have potential energy relative to the sea level, and if the water does not infiltrate the ground, it will run off as surface water, run off into lakes and streams. Here, the potential energy is changed into kinetic energy and chemical energy. The importance of surface water is sorry. The proportion of rainfall received at the Earth's surface, which runs of either channels or flow and overland, it is distinguished from the rest of the rainfall, which either percolates into the soil or evaporates into the atmosphere. Here, as you can see, impermeable. So this should be impermeable rocks which do not get weighed down by the water. When the runoff water from the surface gets run off into the lakes, they infiltrate the soil, and when they build up and form lakes and rivers and form the channels which the lakes and streams flows in.
The importance of surface water is far greater than the runoff involved. It is surface water which has played a major role in erosion and shaping of the Earth's surface. As well, the flow of surface water in streams and rivers has played an important role in the stream of civilization. Excessive water also brings from time to time the hazard of floods and their catastrophic results. Thank you. Any questions?
Okay, questions from the class on the process surface runoff?
Just before you ask questions, I'll just explain on this one. Here. The water that gets infiltrated or seeps through the soil, it doesn't. Sometimes it may resurface, come up as resurgence or springs. So you can see in our diagram here, rainfall in a area, high region, and the water flows down and may come up as springs and lakes, or not lakes, but wells. Any questions?
Questions from the class? Kiran, you have a question now? Okay, if there are not going to be any questions for this group, or there is a question here? No? Okay, we'll put our hand together then for this group on their presentation. Okay, quickly looking at what they have covered and the two nice diagrams that they have constructed. Surface runoff. We've done a lot of work already on rivers. We've studied about rivers and how rivers are important agents in sculpturing the Earth's surface. Rivers are just one of the examples to show us surface runoff. Any water which is on the surface is classified or considered as surface runoff. And because the previous group has already explained about infiltration, we need to also understand that for surface runoff to occur, it would have to go through the stage of infiltration, and when infiltration cannot further or any longer take place, the excessive water on the surface then makes up the surface runoff. If it is confined in a stream or a bed, it becomes a river. I'll repeat that again. If the water is confined in a channel, then it becomes a stream or river. If it is in a lake form, or it could be in a creek form, as long as it is on the surface, then it is to do with surface runoff. But for surface runoff to occur, it must go through the process of infiltration first, and when further infiltration cannot take place, the water that stays on the surface then will make up the surface flow or surface runoff. The diagram here that this group is trying to explain, it gives us example of a spring, and a spring is basically to do with natural occurrence of water up on the surface, and springs occur as a result of infiltration, first of all, into the different permeable rocks until they reach a layer of impermeable. They cannot flow anymore, or they cannot stay on the surface or infiltrate anymore. So therefore, where the impermeable layer, where it meets the surface, what will happen is the water falling from elsewhere will flow out. Once it infiltrates, it goes into the ground. But then because of the impermeable layer, the way the rocks have been placed, where the impermeable layer meets the surface, that's where we have springs occurring. So just in case you're wondering about this diagram here perhaps is showing us one way in which springs are formed, and springs are also examples of surface runoff. So this is only for the formation of a spring and how a spring is formed. So if you look at this diagram again, the way in which they have constructed these impermeable layers, they are lying across in a hilly country, 1, 2, 3. The exposed areas, this section here is exposed on the surface. But this layer here is supposed to be the permeable layer. So rain comes through, it will come through the permeable layer here, but because it is infiltrated under the surface, it will flow as underground water. But where the permeable layer meets the surface, the water can be forced to come up, and that's where springs are formed. But this is what the diagram is trying to show you. Okay? Surface runoff, any water on the surface will make up that particular feature. And because we will already also have run out of time, the other groups then will continue with the presentation in our next lesson. This then will conclude our presentations for today. Class, if you can now stand up. To the pilot teachers, our keyword for lesson 113 is dew point. Good afternoon and thank you, students.